Welcome back friends. Welcome back to another video session from this channel. So in this video session, we will be studying regarding the various unusual codons which do exist in the genetic code. Is it okay? So before studying regarding the various unusual codons which do exist in the genetic code, at first let us have a look. What is the basic difference in between usual codons and unusual codons in the genetic code? Is it okay? So if we consider the usual codon like AUG, is it okay? AUG is the codon which encodes a specific amino acid known as methionine. Methionine, right? AUG codon, it encodes methionine amino acid, either in case of prokaryotes or in case of eukaryotes, or in case of primitive organisms or in case of complex organisms. So the reason why AUG codon, it is considered as an usual codon because it is very specific to one particular amino acid nearly in case of all the living organisms. So the reason why it is considered as usual codon. Then what about unusual codons? So as the name itself suggests, unusual codon, that means the specific codon, it is not very specific to one particular amino acid, or the specific codon, it is not very specific to its function. So the reason why they are termed as unusual codons. Is it okay? No. So let me write it here. Unusual codons. So what are the various unusual codons which do exist in the genetic code? So if we consider UGA, is it okay? So UGA, so as we all know, in nature or in case of genetic code, there is an availability of three different stop codons or termination codons, right? So what are the three different stop codons here? UAG, UGA and UAA. So why they are termed as stop codons or termination codons? Because this specific codon, it do not encode any specific amino acid which do exist in nature. So the reason why the specific codon, it is termed as stop codon or termination codon. Its responsibility is to inhibit the polypeptide chain synthesis or the protein synthesis. So the reason why the specific codons, they are termed as stop codons or termination codons. Is it okay? But in case of certain living organisms, the specific UGA codon, it won't act as a stop codon. In case of certain living organisms like mycoplasma and spiroplasma, is it okay? In case of certain living organisms like mycoplasma and spiroplasma, the specific UGA, which is a stop codon, nearly in case of all the living organisms, it encodes a specific amino acid known as tryptophan. Is it okay? So the reason why the specific UGA codon, it is considered as an unusual codon. Is it okay? In the same way, there is an availability of one more other unusual codon. So what is the other unusual codon here? CUG. Is it okay? CUG is the codon which encodes leucine amino acid nearly in case of all the living organisms. But in case of yeast mitochondria, the specific CUG codon, instead of encoding leucine amino acid, the specific CUG codon, it encodes threonine amino acid. So let me write it here. CUG, it encodes leucine amino acid nearly in case of all the living organisms. But whereas in case of yeast mitochondria, the specific CUG codon, is it okay? The specific CUG codon, it encodes threonine amino acid. So the reason why CUG codon, it is considered as an unusual codon. And what are the other unusual codons here? The other unusual codons include UAG and UAA. So as I have already mentioned you, in genetic code there is an availability of three different stop codons. So what are the three different stop codons here? UAG, UGA and UAA. So as we have already discussed regarding UGA stop codon, and right now we are going to study regarding UAG and UAA. The specific UAG and UAA codon, they act as a stop codon nearly in case of all the living organisms. But in case of certain living organisms like Tetrahymena and Paramecium, the specific UAG and UAA codon, it won't act as a stop codon. So instead of acting as a stop codon, the specific UAG and UAA codon, they encode a specific amino acid known as glutamine. Is it okay? So let me write it here. UAG and UAA. So they act as a stop codon, right? Nearly in case of all the living organisms. But in case of Tetrahymena and Paramecium, the specific UAG and UAA codon, it encodes a specific amino acid known as glutamine. So the reason why the three stop codons or the three termination codons, they are considered as unusual codon. In addition to the three stop codons or termination codons, the other usual codon, which is nothing but CUG codon, it is also considered as unusual codon because nearly in case of all the living organisms, the specific CUG codon, it encodes leucine amino acid. But in case of yeast mitochondria, the specific CUG codon, instead of encoding leucine amino acid, it encodes a specific amino acid known as threonine. So the reason why CUG codon, it is considered as an unusual codon. So this is regarding unusual codons in the genetic code. So I hope that this video will help you a lot. So if you like this video, just hit the like button and share it to your friends. And I remember you people to subscribe my channel for getting more and more videos what I make day to day. Thank you.